In this video, we're going to cover all things linear regression. The first thing I'm going to do here is introduce our data. So this is from a series of videos that I built called A Dozen Methods, One Data Set, which was a walkthrough of how to use a method map decision tree and the way in which you best select a method given the question or problem you're working with and the structure of your data you have. So it's the same data set that I'm going to use here for our example. This is a set from a college, 4-year college. And the goal here was to try to predict the first year GPA. And then from there, predict the probability that a student would be on probation in the spring. So these are the two core variables we're working with. In addition, we have 4 ACT math scores that range from 1 to 36. Binary variable about whether or not a student was decided or undecided about their major. A binary variable for male, female. Age, which is a continuous variable ranging from 17, I believe, to upwards in the 20s. In-state residency, so 1 for in-state, 0 for out-of-state. Legacy status, whether or not somebody in the family was a graduate of the institution, so 1 for legacy, 0 non-legacy. Binary here. Campus living status, 1 for living on campus, 0 for not. Whether or not a student is employed by the school, 1 for yes, 0 for not. 1 for using tutoring and 0 for not. Same for supplemental instruction, which is an academic category. 1 for using it, 0 for otherwise. And then whether or not a student is associated with a fraternity or sorority, 1 for Greek, 0 for not. So we're going to go ahead and go to analyze. We're going to go to regression, linear. And I already have these blocked in here. So first year GPA is our target, is a continuous variable. So this is the right fit. We have a series of continuous and binary or categorical variables that we're using. All of these are actually binary, so it's not going to split up in multiple categories. So like, for instance, if that was major and there were 5 or 6 different majors, it would read this completely differently than looking at it in a binary. And when I get to the actual regression equation and how to use it, we'll see what that means. So we've got our 5 components here that are academic preparedness is what I'm essentially calling this. Demographics, male, age, in-state residency, whether or not there's legacy status, living on campus by itself, employed by the school, and then 3 academic factors using tutoring, attending SI, and Greek affiliated. We're going to keep this as enter. We're not going to run it stepwise. That'll be another video for another time. We have statistics. So the default is it's going to give you an estimate and a model fit. I also added collinearity diagnostics, so we checked that. And then I added the selection for Durbin-Watson for the residuals. It's going to check for an independence assumption that we're going to get to towards the tail end. We're also going to plot. This is going to look for 2 major assumptions we're looking for. We're going to put the Z predicted and the Z residuals, so the Z scores of these, into a plot. And we're going to look at how that plot performs and what it suggests about whether we are violating any assumptions about linearity and normality and homoscedasticity. And I'm also going to check the histogram and the normal probability plot, the PP plot, for standardized residual plots. And that's all.